Good afternoon, everyone. Welcome to this session number 285. And in this session, I will try to solve this problem. It's a hard problem. It's the minimum obstacle removal reach corner. One moment. I will share this transmission in Twitter. Okay, nice. Now, okay, this is the problem. You are given a zero index 2D integer array grid of the size m per n. Each cell has one of two values. 0 represents an empty cell, and 1 represents an obstacle that may be removed. You can move in up, down, left, right from into an empty cell. Return the minimum number of obstacles to remove, so you can move from the upper left corner to the lower right corner. Yeah, reach this, go to this, do this. This case, for example, is 1, 2, 3, no, 1, 2, 3, 4, 5, 6. We can move from the 0, 0 to return the minimum number of obstacles to okay, the minimum. In this case is not necessary because reach this. Okay, this is very similar to another problem that I did before. Yeah. But in this case is at most k element. Okay. One moment. Okay, it's here. Okay, now. Okay, I think that I need to move to middle. I will copy this. Okay, and we have this grid. Okay. Okay, for this, I think that is DFS because I need to reach this point, but let me check. Maybe I am wrong. Okay, the first is that I start here. Okay. I start here and the goal is this. Okay. Now the idea is that transversal or reach this point with the minimum number of walls broken. In this case, for example, one path is 1, 2, 3, and 4, and the minimum was 2. Another is that 1, 2, 3, and 4, and in this case is 2 again. Another that is 1, 2, 3, and 4, is 3, the minimum is still in 2. Now the next that is 1, 2, 3, and 4 is 1, 2, 3. Another is this is 3. Yeah. Okay, I think that I need figure out all the paths or possible paths and have the count the number of steps for reach this cell and the number of blocks broken to reach this. Yeah, this is the goal. This is the goal. Okay, now is, for example, this is step 0 and walls bracket 0. Now moving this direction is 1 and is 1. Now moving in this direction is 1 and 1, and it's all. Now the next step is this. Moving in this direction is 2 and 2. For down is 2 and 2, and that's it. Now for this is 2 and 2. And okay, now here is 3 and 2. Now this is 3 and 3, and for this is I reach 4 and 3. In this case 4 and 2. The minimum is 2. But I think that if any in the moment that appears 0, I need return this value. It don't make sense continue with the process because you know the minimum is 0. Okay. I only have the though when I reach this. Oh no. When I what happens if I have the next? This is a wall. This is a wall. No, this is a wall. This is another wall, and that's it. I start here, and the target is this. Okay. Now the first that is 0 and 0. Now here is 1 and 0. The first is a step. The next that is the counter. Yeah. In this case is 0 because don't have any element. Now for down is 1 and 0, and that's it. Now applying the BFS, the next that is this. Go to the left. No, because has been checked before. With this, I think that is where the cell has been checked before. For another one is ignore. If the number of a counter is similar, in this case 0 and 0, yeah, is ignore. Now top is out of the range. To right is 2 and 0, and to down, let me move this, 2 and 0, and to down is a block. In this case is 2 and 1. Yeah. Now the next step is this. To right, to top, no, because have the same. To right, yeah, is possible. In this case is 2 and 1. Okay. In this case is this. is 2 and 1. For down is 1, no, 2 and 1. And that's it. Now the next that is this. For left, no, because it's similar. Top, no. Right, no. Down, 3 and 0. And that's it. Now the next that is this. For the left, is in this case, if I move in this direction, is 3 and 1. Top is 3 and 1. Why? Because maybe it's 1, 2 and 3. This is another path. Now for the right is different, means that 3 and 1, and for the down is 3 and 1. Yeah, now the next that is, I think that is this 2 and in this case is 3 and 1 is done. Now the next that is this. For down is 4 and 2. And now 3 and 1 is 4 and 2. Yeah, now here is 2 and 1, 3 and 1. 3 and 1 in this case is 4 and 1. We have the first. Yeah, I think that on the final I will I reach n times. I don't know how many times, how many times, but n times this, and it's only get the minimum number that appear in this. Okay, in this case, for this problem, is that every cell contain a list with the possible number of counter. Yeah, in this case, for example, this could we have the 0. The number of step is doesn't matter, but it's the number of but in this case, what is the meaning, or what is the reason to use the steps? Don't make sense, you know. It's only, yeah, I think that, yeah, the first is completely ignored. Don't make sense that use the number of steps, because and the final I need return only the number of minimum obstacle that I need broke to reach the target cell. Means that is only, okay, in this case we have 0. Now here is 1, no, 0. Now to left it has been checked in with the same. Top is out of the range, right, and bottom in this case is 0 plus 1 is 1. Okay, now the next that is this. To left, no, because it's the same. To right, no. To no. Now the next that is this. To left, no. To right, no. To top, no. To right, no. To down, yeah, in this case is 0. And the next that is this. To left is possible, yeah, in this case is 1. Yeah. To top is possible, yeah, because has been checked, but with the number of blocks in 0. In this case is with 1. Now the next is left, top, right, and bottom. Yeah, in this case is this. Now the next that is I think that is this. Left to top is possible, yeah, in this case is 1. To right is possible, no, because have the same. To bottom is possible, yeah, but it's 2. And that's it. Now it's complete. Now the next that is this. No. Here. To the left is possible, no, because contain the 1. To the top, no. Right, yeah. Bottom, no, because it's the same. Okay, it's complete. Now the next that is this. To left, no, because have the same. To top, no. To right, no. To bottom, yeah, in this case is 1. Yeah, we have the first. Now, what is the next? The next task, I think that is this. Or this. Well, in this case, if I move in this direction, it's 2. Another 2. To top, no, because have the same. To this, no, because have the same, and it's done. Now for this is to left, no. To top, yeah. To right, yeah, and that's it. Now this to left, no. To top, yeah. To right, yeah, and to down, no. Now here, left, top, right, and bottom. Left, top, right, and bottom. Left, top, right, and bottom. And left, top, in here 2. I think that in the 0, in this case, it's possible to avoid all the what is happening with the 0. I think that maybe I forget to do this operation. Yeah, but I think that in essential the algorithm is only handle the minimums. Yeah, in this case, for example, 0. Even with a hash set, I can validate this. Instead, only have a hash set with the position of this, or even with a string. For example, the row, column, and the number of counter. See, and this is counter. Yeah, and handle this, and when you reach this, it's only keep the minimum, and if I pick the 0, return all the time 0. Yeah, because don't make sense continue with this process. Okay. Now here I think that I need handle the directions it's equal new int, and here hold on. Okay, here I need a clear now here initialize this directions, it's equal this, and now the direction is left, top, right, bottom. The first is that the first is a row, and the next is call. Left is 0, less 1. Yeah. The next that is top is 1 and 0. Left, top, right. In this case, right is 0, 1. And the last is that bottom. That is less 1, 0. What is the accept that rate? Okay. Now I have this, we have the direction. Now the next that is have a hash set of the strings. Now, even with a simple array, sin it's equal new hash set yeah. Now the next that is yeah, sure, q in this case the q is of integer. Q is equal new linked list. Is linked list or linked list. And now the next that is okay. I need to create the array. Array it's equal new int, and in this case we have 0 0 because it's the column, the row, and I need validate that the grid in this position, in the position 0 0, if it's equal to 1. No, I think that it's not necessary validate this. If it's 0, it's return 0. If it's 1, it's the same number. Yeah, in this case it's only grid in the position, row and column, and 0 0 0. Yeah, and in this case it's row, call, and counter. Okay, I think that now it's done. Now the next that is a while, and is meanwhile q is empty but negative. Integer size it's equal q dot size. I am thinking that if I detect that exists one path with minor values, for example, if I don't know, for example here, do you imagine that this is 3? Okay, I am here, yeah, for which this is 1 2 and 3, and do you imagine that this is a wall? Now if for reach this only take 2 blocks, no, I need to forget completely the steps. It doesn't matter. Okay, now for example this is 3. Do you imagine that this is a wall? For reach this is 3. If I check the previous and contains a minor value, don't make sense continuing in this way because you have the minimum. Yeah, in this case I think that I only every cell should be have let me think. I think that is only keep the minimum number in every cell. Oh. Yeah, for example, in this case, the minimum number to reach this is 1. is 1. 1. Now for down is 1. For this is 2. For this is 1 and 2. And for this is 2. Now for example, for this is 2 again. For this is 2. In no. Okay, I start here. This is the first, to left, top, right, and bottom. Okay, now the next step is this. To left, well, in this case the minimum is 0. Yeah. When is 0, I can disable, yeah, this. In other case, for example, this is 1 is greater than the 0, the minimum. I think that I can create another matrix that represents this, but in this case all contains the 0. No, this is wrong. 0, 0, 0. No, I think that I fill with the max number. Yeah. Why? Because in this way I can move in this direction. For example, the next have greater value than the current, in this case 1. Yeah, because it's maximum. Do you imagine that this is maximum? Okay, I can move and update this with the value of 1. In this case, for example, if I am moving in this direction and I am trying to move here, the number of blocks is 1, 2, is 3. No, sorry, 1, 2, 3. But 3 is greater than 1. Don't make sense continuing this path because it's greater. Yeah. Yeah. And only use this as a structure to help us to know for which path I need to do it, or I need to transversal. Okay, in this case, this is removed. And now here is sin, no, min, and in this case is min, it's equal new int of the size grid dot length. Oh, let me check the constraints before. The constraint is m, it's equal grid length, and it's equal, okay. It's not a square matrix. Could be, but it's not mandatory. The minimum is 1 if so 1. Okay, the index 0, the first and the last are 0. Okay, means that this is not necessary because we know that is 0 in the beginning. Now here is grid.length, and here is the same, but in the index 0. And next that is fill the matrix. In this case is, I know that Java contains or have a function that helps us with this, but take I it's equal 0, and while I it's minor that min.length row plus plus. Now the next that is a 4. Now this 4 is integer call, it's equal 0, and while call it's minor that min in the position row dot length I plus call plus plus, and now is min in the position row and call it's equal math dot integer dot max value. Yeah, and that's it. Now I have completely filled a full this a copy of this, but with the maximum values. Okay, Now the next that is create a queue with these values. In this case, this is the counter. Get this, and now the next that is a for that integer I is equal 0, when I is more that size I plus plus, and now here integer item is equal it's equal q dot remove. For example, in this case is this. Now is validate or apply the BFS and the direction. Yeah, in this case the possible direction are integer dir directions. Yeah, now the first is validate if, you know what, I will create here row it's equal item in the position 0. I prefer it this way. I think that is much clearer. Is yeah, it's better. Call and counter. This is 1. This is 2. Okay. Now, for example, the direction are left, top, right, bottom. Now, if the left is that integer new row, it's equal row plus dir in the position 0, new call it's equal row, no, call in the position 1, and new counter it's equal counter plus this. Yeah, in this case, if in this position, this new position, in the matrix, in the mean, that is the matrix, this, if mean in the position new row, new call, if the value is greater than new counter, I can add, yeah, q.add new int with these values, because again, don't make sense performing an operation for one path where is greater than the previous state or the previous value. In this case, is new counter. Yeah. And where is n? Yeah, in here I only need return the minimum. In this case is only return mean in the position row, no, mean dot length less 1, and this is the same, but 0. It doesn't matter the row. And I think that with this should be work. What? Integer call it's equal 0 call variable error. What is error? Row. Okay, I am return. Why I don't reach the final? If the value is greater equal case don't reach the element, but why? I am here and I this contain the maximum number. What is the minimum? The minimum is this. Okay, is add this in the queue with the value of 1. Sure, and I need to update this value, you know. Here, set that. Now the new value is a new counter. Okay, still with the same, but this is the idea. Main in the position in row, a new column, it's equal new counter. The new minimum. But why I don't reach the final? Left. And even it's strange, but here I should be why I don't get an exception. Should we get an exception, right? Because in the top, if I am here and I am trying to reach this, it's not possible. Why I don't get why I don't receive this exception is because it's not execute. Okay, let me check here. We start in the 0 0 0. And obviously the first, in this case min, in the position 0 and 0, it's equal 0, is the minimum. Yeah. Okay, now receive the position 0, the size is 1. Now it's transversal this. Now it remove the item 0 0 0 and it row that is 0, column that is 0, and this is 0 2. Now the first direction to check is the left. Its directions is this: left, top, right, bottom. Remove 0 0 and 0. Now check the left. I think that is maybe for this conditional don't broke, but I am here. That is marked is disabled this. And now is to left. In this case is 0 less 1. In this case min in the position this and less 1. What? Let me check, because I have my doubt why I is not breaking or broken the code here. Why? It's not execute. Why? Sure. I in any moment I add this. I forget the add this array in this. Even I can ignore this and only add here. Oh my gosh. Yeah, now appear this. For this is easily, it's a simple function. Boolean is valid, and in this case I receive the integer row, integer call, and I need to declare here integer row, integer call, row it's equal grid.length, and the column is the same or very similar. Now is R and C, and here return if R is greater equal 0 and R is minor that row, and call is greater equal 0 and no, this is C, and C it's minor that call. Yeah, it's only that, and put here. Now here is a new row, new call, what? Dir, what is dir? Direction, yeah, sure, it's not this, is mean in the position mean in the position now here okay, here I need have this calculus in after this. Yeah, new call, yeah, and have here new counter, and new counter, new counter. Let's 4 and let's 6. Check the left, this case the left, the first is valid if it's inside the range, and next two is get the current value of the this. If this is greater, this is greater than the counter plus, no, this is wrong. No, here is a grid in the position new row in new column. If it's 0, it's still in the same. If it's 1, it's increase. Yeah, I think that I can move this again. Integer new counter, it's equal this. No. No, yeah, this is necessary to do at this point. This is updated. This is updated. Okay, I will submit. Time limit exceeds. What is the result of this? I don't say it. I don't know how optimize this. I think that is where reach this element. Yeah, here. Here. If the position is this, if row it's equal this, and call it's equal this, and here a minimum integer mean it's equal math integer dot max value. Here is a mean it's equal math dot mean between mean and counter. Yeah, and ask if mean is equal 0. Return 0. Yeah, stop the what? Yeah, sure. Result. Well, okay. Here I can return result. What? Math.mean math.mean, yeah, mean, no, this is result in the counter. is greater than this, what is greater, basically this is moved to this, and maybe it's for this. What do you think? Okay, let me remove this only for it's for this field. Okay, I think that I can yeah, where is 0, change this value to less 1. Init matrix with values Java. No, I think that exists, and no, erase the field Java. But how works field Java doc? Erase dot field here. With the integer this. But the time complexity, what is the time complexity of this? Field, no, is this specific value to each element at the specified right of ints. Parameter, but what is the time complexity? Time, runtime. How works in Java? Yeah, but don't say. I don't see. I can see what is the time complexity of how works itself the function. Overload difference that day. There is a variation field specific range. It's the same. Yeah, but it's for this. here the item. I think that I can change the 0 for less 1, and where I detect the 0, take as a maximum value. Yeah, or change as a maximum value. Here I need to change this. If this or this is equal 0, yeah, because the 0 is the initial state, I do this. Who works erase dot fill time complexity. Yeah, it's exactly the same. Okay, here is 0. Now if counter, no, yeah, here if grid integer r is equal, if this in the position new row new goal, you know what, here is if this is not valid, continue. Yeah, now in this case I'm sure that this exists, and if this is equal 0, I can take it that this is the maximum. Return integer dot max value. Other case, return the value that is contained here. Yeah, it's for this. Now I need to figure out how use this matrix without initialize. But well, I think that in the next transmission. But thanks for following this transmission, and I hope see you in the next.